welcome back to my channel. So I'm back with question paper of MasterCadre Science that was held in June 2021. So let's start the discussion of the paper. So we have already done first 16 questions. Now it's time to solve the 17th question. Before that, please subscribe to my channel and like all the videos. Thank you in advance. So let's start the question. The first question says, when 48 grams of methane is burned with excess oxygen, how many grams of carbon dioxide are produced? So let's do this. Whenever any hydrocarbon is burnt in oxygen, carbon dioxide as well as water is produced. So let's write the equation. CH4, that is methane, and oxygen gives you what? Carbon dioxide plus water. Right now you can balance the equation. So your equation will be like this, right? And now you can clearly see 1 mole of methane is producing 1 mole of carbon dioxide. So let's calculate the molecular mass of methane and carbon dioxide. The molecular mass of methane is CH4 is, the mass of carbon is what? 12. Now the mass of hydrogen is 1. The answer will be 16, right? Now the carbon dioxide produced is what? Molecular mass of carbon dioxide is, now the mass of carbon is 12 and the mass of oxygen is 16. The answer comes out to be 44 grams. Now from here, it is quite clear that 16 grams of methane is producing 44 grams of carbon dioxide. So let's substitute the value. 16 grams of methane is equal to what? 44 grams of carbon dioxide, right? Now we can calculate the values corresponding to 1. It will be 44 divided by 16. But in the question, we are having 48 grams of methane. So 48 grams of methane will be 44 divided by 16. Multiply by 48. The answer will be 132 grams. So the answer is 132 grams. That means option number C is the correct answer. The question was very easy. Again, the question is from +1 class. The next question is, to which period and the group does the element with electronic configuration 287 belongs? So find out the total number of electrons. Now let's write K, L, M. 287. How many shells are there? 3 shells, right? That means the period is 3. How? Because period is equal to number of shells, which is equal to 3. Now we are having only 2 options having third period, that is A or C. Now we are going to add the number of electrons. 2 plus 8 is what? 2 plus 8 is 10. And 10 plus 7 is 17. So the answer is 17th group and third period. The correct answer is option number A, right? Now moving to the next one, 19th question. The most probable speed for hydrogen molecule at 0 degrees Celsius is what? The formula for most probable speed, is under root 2 RT by M, whereas R is gas constant, T is temperature in Kelvin, and M is the molecular mass of your molecule. Now in the question, we are having hydrogen molecule, that is H2. So the molecular mass of hydrogen molecule will be 2 grams, but we have to take the mass in kilograms. So we have to multiply it with 10 raised to power minus 3 factor, right? Now at 0 degrees Celsius, what is 0 degrees Celsius? It corresponds to 273 Kelvin, right? 273 Kelvin. Now let's substitute the values and find out our answer. So 2 into 8.314 into 273 divided by 2 into 10 raised to power minus 3. So on solving this, what we got is 1.50 into 10 raised to power 3 meter per second. The question is very, very easy. You just have to employ the formula. The formula is under root 2 RT divided by M, where R is the gas constant, T is the temperature in Kelvin, and M is the molecular mass of your molecule. So for hydrogen molecule, the answer is 2 grams. Now we have to convert this into factor into what? We have to convert this factor into kg. So that's why we are multiplying it with 10 raised to power minus 3 kg. Now for 0 degrees Celsius, the temperature is 273 Kelvin. So on solving this, what we got is 1.50 into 10 raised to power 3 meter per second. You just have to use the formula, right? Now, the next question is for ortho and meta di substituted benzene with theta is equal to 60 degree and theta is equal to 120 degree. The ratio of resultant magnitude of the electric dipole moment is what? Now for meta dipole moment, for meta is under root 3m, and dipole moment for ortho is m. Okay. Now, after solving this, we have to find out the ratio. Okay. So let's find out the ratio. Under root 3m divided by m. It is under root 3, and the value of under root 3 is 1.7. Right? So the answer comes out to be option number B. I hope you know about what are ortho and meta di substituted benzenes. That means there is substitution at first and the second position, and there is substitution at 1 and 3rd position. With di substituted benzene, that means there could be any substitution. It could have any halogen group. It could have any group like halogen or alcohol or nitro group. Any group can be there. Di substitution means there is presence of 2 functional group. It could be same, it could be different. That is the other thing. All right. So for ortho means what? 1-2 substitution, and for meta it means 1-3 substitution. Right. Now moving to the next one. The next question is arrange the following. The next question is arrange the following in decreasing order of bond length. So let's write down. This question is again from class +2. So let's solve this question. Write down bond length is inversely proportional to bond order. Is inversely proportional to bond order, right? Now for O2 molecule. For O2 molecule, the total number of electrons in bonding orbital, okay, write down total number of electrons is 16, right? Now we have to find out the bond order of this. It will be 10 minus 6 divided by 2. The answer comes out to be 2. Now formula of bonding orbital, like bond order, is electrons in bonding molecular orbital minus electrons in anti-bonding divided by 2. Okay, so using this formula, what we got is 2. Bond order is 2 for O2. Moreover, you can write the electronic configuration, that is sigma 1s2, sigma star 1s2. If you want to write sigma 1s2, sigma star 1s2. Then we are having sigma 2s star, sigma 2s2, sigma 2s star. You can write it, right? That is not much required over here. So let's move to the next one, that is O2 positive. O2 positive means 1 electron is lost. So 16 minus 1 is 15. Now we have to find out the bond order of this. So the bond order is, what will be the bond order of this? It will be number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbitals divided by 2. The answer will be 10 minus 5 divided by 2. 10 minus 5 divided by 2, that is 2.5, right? And similarly for O2 negative, O2 negative, the answer will be 1 extra electron will be there. Now it will be 17. So let's calculate the bond order for this. So bond order is number of electrons in bonding molecular orbital divide minus number of electrons in anti-bonding molecular orbital divided by 2, right? So the answer will be, let's find out the answer. So bond order will be 10 minus 7, that will be 3 by 2. The answer comes out to be 1.5. And similarly for O2 negative, let's find it over here. O2 negative, the electrons will be 18 in number because O2 has 16 and 2 more. The number of electrons will be 18. Now we have to find out bond order. It will be 10 minus 8 divided by 2. The answer will be 1. Now let's arrange the bond order. So bond order is like 2.5, 2, 1.5, and 1. It is bond order, right? So 2.5 for O2 positive, 2 for O2, and 1.5 for O2 negative, and 1 for O2 negative. Now we have to find out the bond length. Bond length is inversely proportional. So bond length will be reverse order of this: O2 negative, O2 negative, O2, and O2 positive. That is option number A. For 21st, it is option number A. Now moving to the next one, 22nd question. A proton HB is coupled to 4 equivalent protons HA. The multiplicity and the relative intensity of light lines in the signal HB are what? So the formula is very well known to you, n plus 1. Now 4 plus 1 is what? 5. That means there will be 5 signal. So triplet are eliminated. Now we have to look out this. Now I hope you know about the Pascal triangle. Pascal triangle is 1, 1, then 1, 2, 1, then 1, 3, 3, 1. After that 1, 4, 6, 4, 1. So for 1, 2, 3, 4, 5. So for 5, the ratio of intensity of lines is 1:4:6:4:1. That is a quintet is observed. What is observed? Quintet, right? And the next question is 23rd question. The 23rd question says, which of the following is the wave number of near infrared spectrometer? So the answer is option number C. You just have to learn out the values, right? And after that, you will get to know. The next question is 2 moles of a gas at 1 bar and 298 Kelvin are compressed at constant temperature by the use of a constant pressure of 5 bar. How much work is done on the gas? So we have to find out the work done on the gas. So let's write the formula. Now work done is equal to minus P delta V. Moreover, we know that PV is equal to nRT, right? So what will be the value of delta V? Delta V is change, right? Delta V is change. That means final volume is V2 and initial volume is V1. So we can find out the value of V from here. So V comes out to be nRT divided by P. So let's substitute this value over there. So it will be what? Fine. We are taking the final pressure over here. So it is minus P2. Now V2 will be nRT P2 minus nRT. Over here it will be P1. So it will be minus 2. Wait, let's take nRT as common and let's move P2 inside the brackets. nRT with negative sign, P2 by P2 and P2 divided by P1. So P2 and P2 got cancelled out. Minus nRT, 1 minus P2 divided by P1. Now substitute all the values. 2 into 8.314. The temperature is 298 Kelvin. And 1 minus the value of P2 is 5 and the value of P1 is 1. So 1 minus 5 is 4. On solving all this factor, what you got is 19820 joule. 19820 joule. That is option number B. Okay, I hope the question is clear to you. You just have to use the formula.
Taking off, find a place with a view. The pain is never gonna stop if it's controlling you. I know that time can heal it all, I just gotta get through.